We're going to do a question in vectors in testing if 3 points are collinear. And so I've drawn 3 points here, and what I wanted to just discuss quickly the idea behind how we're doing this question before we go into it. So if I have 2 points, like just these two here, then it wouldn't make a lot of sense for the question to say, hey, are the 2 points collinear? Because there's always going to be a line between any 2 points that is going to cross both points, right? So that's always possible. So that doesn't make a lot of sense to ask. It's not very challenging. So what we do is we ask whether 3 points are collinear. And here you can see that they're not collinear. But if the third point that we were interested in was actually this guy over here, then those 3 here are collinear. And so we can use vectors to determine whether 3 points are collinear or not. And so just focusing on these 3 for now. If I want to show that these 3 are collinear, then what I have to do is to take these 2 points here, the 2 vectors that are the 2 position vectors that are describing, imagine the origin is over here, and there's a position vector that describes this position and another one that describes this position. Well, from your work in past exercises, you should remember that if this is P1 and this is P2, and the vectors that describe their positions are just those 2 but underlined, then you can say that the vector that points from P1 to P2 is just going to be equal to vector P2 minus vector P1. Right? If you subtract those 2, one from the other, you're going to get the vector that points from this guy to that guy. How is that helpful? Well, if we know this direction, the direction that goes from one point to another, then we can then ask the next question and say, okay, so here's P3 over here. It's P3. What happens if I subtract P3 minus P2? Well, I should then get this vector. Right? And what we do then is we look at these 2 vectors and we compare them. And we say, hey, are they parallel or are they not parallel? In this case, they're obviously not parallel, which means that they're not collinear. But if the third point was over here, if this was P3, then hopefully you can see that the vector that points from P2 to P3, when I subtract those 2, is going to be this vector. And this one and that one are going to be totally parallel. And how do you know if 2 vectors are parallel? You should remember from before that for 2 vectors to be parallel, they have to be a multiple of each other. So for example, if one of the vectors is 2 and 3 and 4, the other one should be 4 and 6 and 8, or it can also be minus 2 and minus 3 and minus 4. All of these vectors are multiples of each other. They're just, this one is just minus 1 times this guy gives you this guy, and 2 times this guy gives you that guy. So these are all parallel. So that's what we're going to do. We're going to make a few subtractions of vectors, and we're going to try to prove that the resulting directions are parallel, and that's how we show that 3 points are collinear. So let's get on with the question. The question says that the points are, let's see, P1 is 1, 2, and 4. P2 is minus 2, 1, and 4. P3 is minus 5, 0, and 4. Now this question has a second part that's actually the trickier one. And the second part says that there's a point P4 that has coordinates 2, y, and z. And that, well, actually the words of the question are not like that. I've kind of given that away a bit. Words of the question say that P4 has x coordinate. They tell you that P4 has x coordinate equal to 2. And that you have to find the y and the z coordinate. And so that's why I defined it as 2, y and z, because we don't know what these two coordinates are, but we know that the x coordinate is 2. And they ask us to find y and z, given that P4 is also collinear with these three. Okay, but before we do that, we need to prove that these three here are collinear. So let's do that, and then we'll go to the P4 part. Get rid of this guy. Okay, so let's do it. We need to subtract these vectors in such a way that we can compare the directions. So let's do P2 minus P1, and that will give me the vector that points from P1 to P2. So P2 minus P1 is equal to this minus that. Minus 2 minus 1 is minus 3, 1 minus 2 is minus 1, 4 minus 4 is 0. So this is the direction vector that points from P1 to P2. Now let's compare that with the direction vector that points from, well, we can do either. We can do from P2 and P3, or we can do from P1 to P3. Either one. If they're parallel, we're fine. So let's do P2 to P3. Why not? Let's do that in a different color. P2 to P3. So to get that vector that points from P2 to P3, we need to subtract P3. We need to do P3 minus P2. It's not a very nice 2, 1, and 4. Okay. Minus 5 minus 2 is minus 5 minus minus 2. So be careful there. It's very easy to do it wrong. So that's actually plus. Minus 5 plus 2 is minus 3. 0 minus 1 is minus 1. And 4 minus 4 is 0. So these two are actually identical. They wouldn't have to be. They could be multiples, but they're totally identical. And so the direction of the vector that goes from P2 to P3 is parallel to this one. So we can say, therefore, parallel. So P1 and P2 and P3 are collinear. Excellent. So that part's done. That was not too hard. Let's now do the other part. So if what they tell us is that this P4 guy has a coordinate only of 2, that's the only thing they tell us for the x, then we can put variables y and z here, and we don't know what they are, but we do know that if it is true that it's also collinear with these three, that if we subtract any of these points from P4, right, we should get a parallel line also. So let's do that. Let's do this guy minus one of them. I don't know, I'm going to do P1, which is 1, 2, and 4. It should also come out to be parallel. And that actually is going to give me the clue to find y and z. So what should this subtraction be? Well, it's going to be parallel to this direction. So actually I can write it down. It doesn't have to be equal. It's going to be parallel. So minus 3, minus 1, and 0 is the direction of these guys. But I don't know if it's going to be equal exactly to this. So I need to put a constant here that says that it's going to be parallel. Because that's a condition for parallel vectors, that some multiple times the direction is going to be equal to that one, to the other one. So this is a condition for something to be parallel. That things to be parallel, that's what needs to be satisfied. Hopefully you can see that a constant times this is going to be a parallel vector. And that's our where the place where we can get our equations from. We can now do 3 equations. We can get them from here. So we can do an equation for the x coordinates, which is taken from there. We can do an equation for the y coordinates, because these vectors need to be the same in the 3 coordinates. That's what's useful about vectors. You get 3 times the amount of information. There we go. And then we can use a different color for the z. So all of this needs to be true. So there come our 3 equations. So we get that 2 minus 1 equals minus 3 times k. And from here we can already get our value of k. We get that, well, 2 minus 1 is 1, 1 minus 1 over negative 3. So we get that negative 1/3 is k. So I already know that guy, which is going to help me to calculate y and z. Awesome, that's done. So let's see, the next one is y minus 2 equals minus k. We know that k is minus 1/3, so minus k is positive 1/3. So we get that 1/3 plus 2, 1/3 plus 2 is our y coordinate. We do this by putting them both over 3. So what is 2 to put it over 3? It's the same as 6 over 3. Right? 6 over 3 is 2. So then this is the same thing as doing 1/3 plus 6/3. And therefore, this is 7/3. So now we have our y coordinate to be 7 over 3. We already have half of our question done, and we just need the z. So the last equation is that z minus 4 equals 0, and that's really easy because, well, 0, why? Because k times 0 is just 0, so that's straight away that implies that z is equal to 4. And we have our two coordinates, the y and the z coordinate. So in other words, the question asks us to find the coordinate of P4, and it just gave us the clue that it was collinear. So in order to find the coordinates of P4, we assumed that the direction vector between P1 and P4 was going to be parallel to these, and we made this condition. It means that it's parallel to this other vector, and so for P4 we get that the coordinates are 2 that they gave us already for the x, 7 over 3 for the y, and then 4 for the z. Okay, and if you're not sure about whether that's true or not, you can check it by now doing subtracting between that and one of the other points, the P2 or the P3, and you will get the answer will be some constant times minus 3 minus 1, 0, which means that they're parallel vectors. Okay, hopefully that helps. Let's see you in the next video.